a particle is displaced by 4 meter in the southwest direction and by 5 meter in the east, and then lastly through 6 meter in the direction which is 60 degree north of east. Calculate the total displacement from the starting point. Now here you have got 3 displacements. Let's say the particle begins somewhere here, then it moves in this direction by 4 meter, then in this direction, and finally in this direction. You have to find out the final displacement. Okay, so this was first initial displacement vector, this is second second displacement vector, and this is third displacement vector. So if you wish to find out S, what you have to do is first you have to find out the displacement resultant of the first two displacements, that is S1 plus S2, which is this. Okay, and then this displacement vector has to be added with the last displacement vector S3, so that you get final displacement S. So this will be S1 plus S2 plus S3. Okay, so you have to specify what is the direction as well as what is the magnitude of the final displacement. Okay, now since the directions are given with reference to north, east, south and west, so what we will do is that we will consider this as our frame of reference. Okay, so initially the particle was at the origin O, then it displaced by 4 meter in the southwest direction, which means that it is exactly 45 degree with west as well as south direction. So this angle is 45. So the angle with the east direction is 225. Okay, so this is given by OM vector. Okay, now the second displacement is from M to N, which is 5 meters in the eastward direction. Okay, so this vector is MN. Okay, and then you have 60 degree north of east and the magnitude is 6 meters. So it starts from here. This length is 6 meter and the angle that it makes is 60 degree north of east. That means this angle is 60 degree north of east. Okay, now we have to specify what is the resultant vector or the final displacement vector, that means its magnitude, and the angle that it makes with the east direction. Okay, now let us write all the three vectors, which is OM, MN and NP in rectangular component form. Okay, that means OMX plus OMY, this will be I cap and this will be J cap. Similarly MN will be MN X component I cap plus MN Y component J cap, and NP X component I cap plus NP Y component J cap. Okay, so OM X will be OM cos 225. What is OM? OM is 4 and cos 225 is minus cos 45, or you can write it as minus 2 root 2. Okay, similarly OMY will be given by OM sin 225 degrees, which is again OM sin 45 degree but with a minus sign. Okay, so you will get minus 2 root 2. So OM vector can be written as minus 2 root 2 I cap plus minus 2 root 2 J cap. Now similarly MN vector, if you wish to find out, it makes angle 0 degree with the east axis. So the angle theta is 0 degree. So this mn vector can be written as mnx cos this is mnx I cap plus mny j cap. Now mnx will be given by mn cos 0 degree, so that will be equal to 5 meters, and mny will be equal to mn sin 0 degree, which is 0. Therefore mn vector can be written as 5 I cap plus 0 j cap, or simply 5 I cap. Okay. Now in the same fashion we can write about np vector also. So np vector will be given by np cos 60 I cap plus np sin 60 j cap. The value of np, the magnitude, is 6 meters. Cos 60 is half. This is I cap plus 6. Sin 60 is root 3 by 2 j cap. So this can be finally written as 3 I cap plus 3 root 3 j cap. Okay. Now the final vector r will be given by om vector plus mn vector plus np vector. This comes from polygon law of vectors, polygon law of vector addition. Okay. So if we add om, mn and np, om was minus 2 root 2 I cap plus minus 2 root 2 j cap. Mn was 5 I cap plus 0 j cap, and np was 3 I cap plus 3 root 3 j cap. So if we add the three terms, the three vectors, what we are going to get is 8 minus 2 root 2 I cap plus 3 root 3 minus 2 root 2 j cap. If we calculate the value of 8 minus 2 root 2, it comes to around 5.18, and 3 root 3 minus 2 root 2 comes to around 2.368 j cap. Okay, so this is the final displacement vector r. Now if we calculate the magnitude, this will be equal to under root of 5.18 squared plus 2.368 whole square. So the final magnitude will be somewhere close to 5.69 meters. Now if you find the angle tan alpha, where alpha is this value will be equal to ry upon rx. What is ry? This is ry and this is rx. This is ry and this is rx. Okay. So the value of ry is 2.368 and the value of rx is 5.18, which comes to around 0.457. So we can write alpha as tan inverse of 0.457, the value of which using the anti-lock table or the scientific calculator comes to around 24.56 degrees. So the final displacement vector can be written as having a magnitude of 5.69 meters with a direction of 24.56 degree north of east. Okay, so this is the final displacement vector. Okay, this magnitude is 5.69 and this angle alpha is 24.56 degrees.